So we're going to take some time and talk about quadratic equations that are written in standard form. Okay? When we talk about standard form, what we really want to be looking for is what information can we pull from standard form of a quadratic. My hint to you is there's a lot. There's a lot of good information hidden in the coefficients of the equation that will help us draw graphs, make some inferences. We'll be able to do a lot of different things about the graph just from what we see in the equation. So just a quick review. Vertex form. And we talked about vertex form the other day. Ax minus h squared plus k. That's vertex form of a quadratic. Reason it's vertex form is hk is the vertex of the parabola. Standard form, a little bit different. Ax squared plus bx plus c. ABC. Okay? Now, these two are related. There are some connections we can make from vertex form and standard form and kind of make some connections, look for relationships, whatever you want to say, we can do that. First of all, in both of them, A is the same. A is the exact same for both. Okay? For B, negative 2 times A times H, if you take those numbers from vertex form, that'll tell you what B is in standard form. And then C equals this. Now there's a long little way we can derive this, and basically it involves doing FOIL and then kind of making the equation in vertex form, rearranging it so it looks like the way it would look in standard form. That's kind of a lot. So I'm just going to give these to you. Okay, I'd be happy to show you what it looks like if you want to see what it looks like. Okay. But this is how those three are related. A equals A, B equals negative 2AH, and AH squared plus K equals C. So if the formula says something about C, we know how we can get that out of vertex form. Okay? Because there's some properties of parabolas. There's some good properties of a parabola. The first one is this. The parabola opens up if A is greater than 0. It opens down if A is less than 0. If A equals 0, it wipes out that total x squared and it's a line. The graph will be a regular old line. So boo-hoo, we don't want that. Okay? Axis of symmetry, right? Every parabola is shaped like a U. Parabola. There's an axis of symmetry that cuts our parabola perfectly in half. We could fold it right on top of each other. Okay? We can find the equation of the axis of symmetry from the coefficients. So the axis of symmetry is a vertical line, so it's x equals negative b over 2a. Then, that axis of symmetry runs right through the vertex, which in the case of that red parabola, that's the bottom of it. We can find the ordered pair from the vertex. And the vertex is negative b over 2a for the x value, which makes sense from what we have in the axis of symmetry, where x is negative b over 2a. Then, to find y, we have to evaluate our function at that same number. Last piece of information, my favorite piece of information, the y-intercept. That's c. Whatever c is, that's what the y-intercept is. Now, those conversions we talked about before, right here, they help us so that we can calculate all of this for vertex form. with those conversions. Okay? Now I'm going to show you two examples kind of how that works, so you can see it for both. Now if I were you, I'd write these down. Two examples. Find A, which direction it opens, B, the axis of symmetry, C, the vertex, D, the y-intercept, then E, graph it. Okay? So here's your equation for the first one. X squared minus 6x plus 3. First of all, A, which direction does it open? Well, this graph opens up. It's going to look like a U. Because A equals 1 here, and 1 is greater than 0. B, we got to find the axis of symmetry. X equals negative B over 2A. Negative 6 over 2 times A. A is 1, B is negative 6, C is 3. If it helps you, write that down. A is 1, B is negative 6, C is 3. Okay. That means I got 6 over 2, and my axis of symmetry is x equals 3. Okay. Then we have to find the vertex. We might need a little more room. Move this guy down, move that guy down, we'll come back. Oh, crap. Oh, okay, this is freaking out. Move that down for now, and then we'll come back to it when we scroll down. Okay. In the meantime, the goal is to find the vertex. Now the vertex, we take negative b over 2a and f it negative b over 2a. We know what negative b over 2a equals. That's what's nice about this. So we're going to do 3 for our x value from the axis of symmetry, and then we're going to evaluate our function at 3. So the x value is 3. The y value, holy threes. But we're going to evaluate all of this to figure out what it equals. Okay? So if we do that, move that out of the way, 9 minus 18 plus 3. 9 minus 18 plus 3 is a negative 6. So we have a vertex at 3, negative 6. The last step is to graph. The last step is we're going to draw the graph here. Okay? Let's take what we know. We know it opens up, so it's going to be a U shape. We know that we have an axis of symmetry through x equals 3. We know we have a vertex at 3, negative 6. And guess what? I forgot a letter, so I'll have to stop back and figure that out quick. Okay? I forgot to find out what the y-intercept was. The y-intercept is 3. Because that's what c equaled in our function. If we scroll back up, the y-intercept, which is c right here is 3. So we know what the y-intercept is. That's my bad. I'm sorry I skipped that. That means I got a point right here. Now, this axis of symmetry represents symmetry. That means we can fold up our parabola. So if I have a point at the y-intercept of 3, I have a point exactly on the other side from that, across from the line of symmetry. Okay? Our graph looks like this. Okay? Our graph looks like that. That's the graph of this parabola. Ignore that minimum or maximum stuff. We'll get to that in a second. Okay? Let's do another one. Let's do one in vertex form. Okay? Here's your equation. Now, you don't have a, b, and c when you have this equation. You have x, h, and k. Or should you have a, h, and k. A is 2, h is 2, k is negative 1. First of all, which direction does it open? Well, since the a's are the same, from from vertex form to standard form, this opens up. Okay? The axis of symmetry. Now, if we look at this, the axis of symmetry here, need a purple. The axis of symmetry was negative b over 2a, which was the same value as x from the vertex. Well, in vertex form, h is x from the vertex. So if h equals 2, that means that the x-coordinate in the vertex is 2, which means the axis of symmetry goes through the line x equals 2. So that's actually pretty easy to figure out. So is the vertex. Okay? So is the vertex. We know what the vertex is. The vertex is hk. That's why it's called vertex form, because you know h, you know k. So the vertex is 2, negative 1. We have to work a little for the y-intercept. The y-intercept is c. Okay, we don't know what c is, but we have a conversion for c. A h squared plus k. A is 2, h is 2, k is negative 1. So we have 2 squared, which is 4, times 2 again is 8, minus 1 is 7. So the y-intercept is 7. That went a little bit quicker. Okay, that went a little bit quicker, but once we had the axis and the vertex, it made it a lot easier. Now let's graph. Okay? We have an axis of symmetry at x equals 2. We have a vertex at 2, negative 1. We have a y-intercept c at 7. And we know that due to the axis of symmetry, we have a point on the other side that mirrors our y-intercept. So we put a second point down right there. This graph opens up, which these points look like, make it look like it does. Come down, turn around, go back out. There it is. There's that graph. Okay? So we got a little bit more to talk about just really quickly. We can talk about the maximum and the minimum for every parabola. The maximum or the minimum. The maximum of the parabola is for a parabola that opens down like this. And the maximum is the very highest point. It comes from the vertex, right? That's the y value of the vertex. The minimum is for a parabola that opens up. The vertex, the y value of the vertex, is the minimum. Okay? And why do we care about this? It also helps us determine the range. If we know the maximum, y has to be less than or equal to the maximum. That's going to be the range for these values. Right here, y is going to be greater than or equal to whatever the minimum is. We can calculate domain and range for any parabola. Okay? So let's go back and look at the ones we just talked about, just really quickly. Tons of information from these parabolas. Find the maximum or the minimum of each equation. Well, we know right here, both of these have a minimum. The minimum here. The minimum, we are down here. I want the y value from the vertex. The minimum is negative 6. Don't know why I use parentheses. On this one, the minimum was negative 1. So much good information from such a simple equation. Lots that we can figure out, lots of good information for us here, which is fantastic. So we'll definitely do lots of good practice with this.